Right triangles. Whenever we talk about a right triangle, we knew that we're going to have an angle in that right triangle that gives us a 90 degrees. Okay. And the right triangle has a formula of a squared plus b squared equals c squared. C squared is going to be the longest side. The c is the longest side. It's called our hypotenuse. So if we have a better drawing, this would be my c. And then a would be your adjacent and b would be your opposite. So let's solve for the given triangle. They already have it labeled for you right here. And it said that b is 24 and c is 26. So what do I know? I know the longest side is 26 and b is 24. I know that a plus b must add up to equal c, right? Because c is the longest side. Well, let's figure this out. We have a squared plus b squared equals c squared. And I'm going to plug in what I know. Well, we don't know what a is. But we do know what b is. B is 24. We know what c is 26. Okay, so before I do anything, I'm going to go ahead and square the 24 and the 26 because we know the values of 24 and 26, but we don't know the value of a, so we're just going to leave it alone. And so 24 squared is 576. 26 squared is 676. All right. So now we want to get a, but right now we have a square. And in order for us to do anything, we need a by itself, right? And in order for a to go by itself, we need to subtract the 576. Because it's a positive here, and when I subtract it, it goes 0, it goes away. What you do to one side, do to the other. So we're going to take that 676 and we're going to subtract the 576. And it leaves us with a squared is equal to 100. Let me change my color right here, this pen. So a squared is equal to 100. However, this tells me what a squared is. We want to know what is a. We're asked for what is a. So to undo the square, we must take the square root. All right, guys, whenever we do square, we take an even root of something, we get plus or minus, but since we're talking about length, we're not going to have the negative. So we're only going to focus on the positive. So now a squared, square root reduces down to 1. And I could show you just a little basic algebra. It's power over root, and 2 divides 2 leaves 1. That means I have a to the first, and then it's just 8 because we don't put the 1 in its place. So that was just a quick algebra review. So I have a is equal to the square root of 100, which is 10. When I talk about the square root of anything, this is a root of 2, but we don't write 2 because it's seen as the smallest root. Now, if we go to 3 or 4, we have to write it in. So the question is inside here, we need something that will multiply to itself twice or in a group of 2s. So I got to be able to raise it to a power of 2, whatever I have in here, that's going to equal that 100. Well, I know that 10 squared is 100. I know that 10 times 10 is 100. So my answer here is 10, and that's how I knew my answer. So A is 10. All right, let's do example 2. Example 2 says, all right, we have a square root of 175. And you're asked to simplify this and write your answer in exact form using radicals. So if you type it in your calculator, it'll probably give you a decimal form, and that is not what it's asking for. It's asking for the exact form. So what I would start out doing is see that it ends in a 5. So I'm going to come over here and make me my triangle, my pyramid, your tree. You can make a ladder if you want it. Whatever works for you, but I'm gonna make the tree. So I'm gonna start with 5. 5 is going to be the prime number I want to use. And I want to see, will 5 go into 175? And if so, how many times? Yeah, 5 goes into 175 35 times. Well, I know what 35 is. It's 5 times 7. All right, this is a square root. Again, that's a group of 2. So I just need a group of 2 to factor down, reduce out. And would you agree 5 times 5 is 25, 25 times 7 is 175. This is also seen as 5 squared, or it's also seen as 25, you know. So we take the square root. I'm going to write it multiple ways just so you can see it. I got 5 squared times 7. Well, 7's to the first. We just don't write the 1 there. So if I was to rewrite this down, I could say, oh, okay, 5 square root of 5 squared times square root of 7. Well, the square and square root reduces down and leaves me with 5 because I showed y'all that rule just a minute ago. The 7 doesn't factor out because I have a power of 1 and a root of 2. Those two don't reduce. Or I could have said, oh, I know what it is. 25 times 7, which I know is square root 25 times square root of 7. That's 5 square root of 7. So there's just more than one way to set this up. The answer, though, in this case is 5 square root of 7. Example 3. Example 3 says, simplify by rationalizing the denominator. All right, guys. So one of the rules is you cannot have a root in the denominator. Cube root, square root, fourth root, whatever it may be, you cannot have a root in it. So we're going to have to apply a rule to it to undo the root. Well, I know since it's a square root, if I multiply by the square root of 7, they become whatever the radicand is, and in this case is 7, and I'll show you in a minute. But what you do on the bottom, you have to do on the top. Okay, so let's rewrite it. Now I have 4 times that square root of 7 all over square root of 7. I'm going to write this multiple times just because I'm hoping you can catch what I'm saying. So I can rewrite this since there's 2 of these. They're identical, same radicand, same radical. Then I have square root of 7 squared, right? Or we could have said, since they're both the same roots, we could put the 7 underneath it, so it's 7 squared. Or we could have said 7 times 7 is 49. I mean, there's multiple ways to look at it. But if we look at this one here, we see the root and the square reduces down to 1, leaves me with 7. We see here that this root and this square reduces down, leaves me with 7. We also see the square root of 49 is 7. So my final answer is 4 square root of 7 over 7. Okay. So example 4, find the approximate value of square root of 35. This is where we're going to want the calculator for, because it said find the approximation. And it says round to the nearest hundreds. So if I take and put in my calculator square root 35, and I will get approximately 5.916079783. But it said round to the nearest hundreds. So the hundreds is the second decimal place. And I need to look at the number directly behind it and say, is this number greater than or equal to 5? Is it greater than or equal to 5? And all you need is a yes for one of these. And then if you get a yes, then we're going to add 1 to that column or to the hundreds place and drop the rest off. If you say no, then you're not going to add nothing. You're just going to drop it all off. In this case, the answer is yes. So I get 5.92, and it's approximately because it's not exact. Let's do example 5. Example 5 says, what is the value of x in the simplest radical form? All right, so we're talking about right triangle. So we're going to use that a squared equals b squared equals c squared. And we know what a is and we know what b is. We just don't know what c is. C in this case is called x. So let's just plug in. So I'm gonna say c squared, or you can put in the place x, whichever works for you. A 15 squared plus b 8 squared. Now what I'm gonna do is 15 squared. It's gonna give me 225 plus 8 squared. Well, that's 64. And then we're going to add these two together. So 225 plus 64 gives me 289. And that is c squared. But that didn't answer my question. Even though I know that c is in this case equal to x, we got c squared. So to undo the square, I need to take the square root. So now I have c is equal to the square root of 289, meaning something times itself twice. And in this case, this would be 17 times 17, which again, we know is 17 squared. Or you could just say the answer is 17. So x in this case is 17. All right, let's do number 6. Number 6 says that we have a 21-foot ladder is placed against a vertical wall of a building, with the bottom of the ladder standing on level ground 19 feet from the base of the building. How high up the wall does the ladder reach? Around to the nearest hundreds. So let's draw this. So we have this. Let's see if I can draw a straight line today. Whoops, obviously off to a bad start. Let's do it again. Actually, let's do the bottom first, the base. So we got the base is from the wall out for the building. And now let me draw a straight line. Whoops, whoa. Oh my, I need a ruler right here. Oh goodness. All right, I'm fixing to give up on this. Sorry guys. Thank you for bearing with me. I'm not a drawer. But anyway, so this is a wall of a building. And now we got this angle going from it. All right. And if you will notice, there is a right triangle. This drawn correctly would have a 90 degrees right here. It represents a right triangle. We have this height here, and I'm going to call it X. And when we look, it said that from the ladder to the ground, we have 19 feet. And then it is a 20-foot extension, or excuse me, 21-foot extension. All right, so we got what we need. So what we need to do is plug in the information we got into our equation for, it's called a Pythagorean theorem for the right triangle. This equation, this formula here is. So X is gonna go in the place of my A, but I'm gonna go ahead and leave it as A, but you can put X there. We can go ahead and do it, why not? Just put X there. Because that's my unknown. That's what I don't know yet when we're solving for. All right. B is going to be the 19 feet. C is the 21 feet. So what I'm going to do is I'm going to go ahead and square the 19. Some may say, well, why can't we just subtract it over there, then do it all in one? You could if you want. Just be careful. 361. Let's square the 21. That's 441. All right, and now we need X by itself. So I'm going to subtract the 361 from both sides. This goes to 0. Got X squared is equal to, so I got 441 minus that 361 leaves me with 80. Okay, to undo that root, we know we need to take a square root of both sides. So now what am I left with? I'm left with X is equal to, well, the square root of 80 doesn't give me the exact, but what I do know is that the, okay, let's just say it this way. If I was to take it and divide, since it's an 80, it ends in 0, divided by 5, I know that I get a square root of 16 times 5, which gives me 4 square root of 5. But this here asks you to round to the nearest hundredths. That means it wants it in decimal form. So let's get it in decimal form. I got approximately equal to, because let me just say this is exact form. Since we're putting it in decimal, we're getting approximation. We got 8, 9 point, oops. Let's start over. We got 8, 9, or 0.9, 4, 4, 2, 7, 1, 9, 1. However, it asks you round to the nearest hundreds. The hundreds is in the second place, so we need to look behind it to determine if we round up or if we leave alone. And then just drop the rest off. In this case here, this number is not greater than or equal to 5, so we are going to just drop the extra numbers off, and this is my answer. All right, yay. Let's do this next one. So this next one's gonna have a little bit more work involved. Yeah, so we're gonna have to do some setting up and separating. So we're gonna find the value of each variable. What do I know? Well, I know the angles, right? We got a 45 degrees, a 45. And this is, since it's a right triangle, this is a 90 degrees. So we have 3 angles. We already know about it. We have the hypotenuse side right here. And in this case here, the hypotenuse side has a y there, right? It's the y value. So let's look at it. So the hypotenuse side, and then we have, since this one here is gonna make me work for it. Okay, so we have 6 for my adjacent, this, okay, let's write this. We have y squared plus x squared. Oops, look at me. We have y squared is equal to 6 squared plus x squared. There we go. Okay, so my y squared is my hypotenuse. And now we're looking for the longest side. So that means we have to square root it. And okay, we will say we have x and 6 is our a. Our y, in the place of it, we're going to have, since we have 2 values, we'll have the square root. So my hypotenuse will be the square root of 2 times my x. In this case, or square root of 6 in this case. Plus my x. And let me just back up for a second. This one here is challenging. It's a good challenge, guys. So we end up with this, but this plus sign here, we can't separate it. And so they recognize that when we solved for y, we had to take the square root of both sides to get that undone. So now what do I have? I have y is equal to the square root of 6 squared, which is 36, plus x squared. And we're taking these roots of it. So to solve for this, we need to see what we can factor out. And it leaves me with man, I had a good one going all along. Should have never put that one in. I hate to. Since x is the length of one, the rectangle is length of the leg, x equals 20. How did they get that? Both legs are congruent. Length of the hypotenuse is square root of 2. Neither value is correct. In a triangle, both legs are congruent. The length of the hypotenuse is. Aha, okay. Okay. So I overthought this one here. I was going to make it a little more complicated than it needed to be. So I had to take a moment to rethink it through. Since both the legs are congruent, since both these legs are congruent, then we know the hypotenuse here is going to be square root of 2 times the leg. Well, in this case here, our leg is 6. So I know that my hypotenuse here, and you can call it y because y is my hypotenuse side, is going to be the square root of 2 times the 6. However, I'm going to rewrite it where the 6 is in front. That way it doesn't accidentally get stuck underneath the root. So I know one of my answers. My other answer is x is equal to 6. So it was just that simple. I had overthought it. And it's only because this leg and this leg are congruent of each other. So my answer is x equals 6 and y equals 6 square root of 2. That's it. Overthought it. Oh, wow. Okay. So that ends this session. Thank you.